In this lesson, we're going to review some objectives from Chapter 8. Problem number 1, given a sub 1 equals 4 and a sub n equals 2 times a sub n minus 1 plus 3 for n greater than or equal to 2, we want to write the first 4 terms of the sequence. A sub 1 is already equal to 4, so we're done. A sub 2 is going to be equal to 2 times a sub 1 plus 3. This is a recursion formula. We need the previous term, a sub n minus 1, to get the next term. So to get a sub 2, we're going to replace every n with 2 in this recursive formula. When n is 2, we get 1. And then we write down the rest of the problem. We already know a sub 1 is 4, so we'll import that here. So 2 times 4 plus 3. And that's going to be 11. And this pattern can continue, but all we're doing is taking this term, a sub n minus 1, doubling it and adding 3. So to get a sub 3, let's double 11, get 22. Add 3 to get 25. Likewise, to get a sub 4, we're going to double 25 and add 3. You can show the work if you want to, but if you see the pattern, you can certainly bypass that work. Number 2, simplify and evaluate. Do not use a calculator. Show what factors cancel. Here we have factorials, the exclamation point. Our approach to this problem was to look for the bigger number. So looking at 2, 18, and 20, we'll start with 20. We'll detach the factorial. We'll multiply down by 1 until we get to the next biggest number, which is 18. We'll reattach the factorial. Let's put 2 factorial times 18 factorial down here. We can divide out the 18 factorials. We can multiply the 2 factors in the numerator. And this is easy enough to calculate. That's just 2. And then finishing with the calculator, we get 190. For problem number 3, parts A and B, we have sigma notation, that E-shaped figure. Notice the index of summation is I. We start when I is 4 and we go up to when I is 7. This is the formula that we're going to use to add terms. Notice there's no I in here. So what this tells us is if we start with I equals 4, there's no place to put 4, so we're just going to record 12. This would be the 4th term of a sequence. When I is 5, there's no place to put I, so we just add another 12. We keep adding 12s by counting 6 and then 7 here, so your answer is going to be 48. In part B, the index of summation is I. We start with I equals 1, we go up to I equals 6. We do have an I in this formula right here. So let's import, plug in 1. So 7 times 1 is 7. Plus when I is 2, it's going to be 7 times 2 plus 7 times 3, etc. until we get to 7 times 6. All right, and then with the use of a calculator, if we add all those terms, we're going to get 147. Okay, problem 4. See what we're doing here. It says write a formula for the nth term of an arithmetic sequence. And then we're going to use that formula to find the 12th term of that sequence. So what we should extract from this language is formula arithmetic sequence. That's a sub n equals the first term plus parentheses n minus 1 times the common difference. Right, this is the general formula, but let's customize this formula so we, on this blank, can put the customization based on this sequence. So 7 is a sub 1, the first term, and then it's up to us to figure out what is that common difference. Well, it looks like we're subtracting by 4, so your common difference is negative 4. So over here on this blank, what's requested is a formula for the nth term of this sequence. Is they got us started with a sub n, so let's plug in 7 plus n minus 1 times d, or negative 4. So we wrote a formula for the nth term of the arithmetic sequence. Now we have to find the 12th term. So when n is replaced with 12, we'll replace 12 in here, and then use our calculator to help us evaluate. This will be 11 times negative 4 is negative 44, and then plus 7 is negative 37. Problem 5. What are we doing here? We're finding a sum of the first 25 terms for the arithmetic sequence above. So the sum of 25 terms of an arithmetic sequence, okay, then we need this formula right here. And again, I did mention you could write these formulas down on a sheet of paper so that when you go to take the test, you'll have the formulas available. Okay, so if we're going to use this formula to find the sum of the first 25 terms of this sequence, we have term 1, term 2, term 3, 4, so forth and so on. But what we need is term 25. We need to figure out what is the 25th term in this sequence, because that value is going to go right here. So let's customize to the point where we need to find some values. So n is 25. 25 will go here. And then we know a sub 1 is 7, but I'll wait and put that in a minute. Plus a subscript n, but that's 25. So this is a visual that shows what two terms we need in order to find this answer. So if we're going to find the 25th term, let's go back, since we already have a formula for the nth term of the sequence. Let's go back to this formula and insert 25. So I'm going to kind of do a little side work here. A subscript 25 equals the 7 plus 25 minus 1 times negative 4. When we go to the calculator and do all this work, 24 times negative 4 plus 7 is negative 89. That's not the answer to the problem, but we needed it to import and plug in right here. So now returning to the sum formula, we'll plug those values in, the first and 25th term. All right, and then go into our calculator. The final answer is going to be negative 1,025. And looking at this notation, that's what it's requesting, is just the answer. A few more problems on the back. Six, write a formula for the nth term of the geometric sequence. So this is another formula you could have on your sheet of paper. So this is the formula for the nth term of a geometric sequence. Let's import the values that we have here. So I might as well just get ready and plug it in over here. So a sub n is equal to the first term, 2, times the common ratio raised to the n minus 1. So it's up to us to determine what are we multiplying by to get every next term. Well, 2 times negative 3 results in negative 6. Negative 6 times negative 3 results in 18, and so forth and so on. And just reminding you that the way to find that common ratio is choose two consecutive terms, take the later term, divide it by the previous term, and the result will be your common ratio. Likewise, 18 divided by -6 would also result in the -3. Right, and then to finish by finding the 10th term, we just replace n up here in the exponent position with the 10. And remembering when you go to your calculator, parentheses are important, -3's in parentheses, raised to the 9th, then go back and multiply by 2. And that's the final answer. Problem 7 says find the 15th partial sum for the sequence above. The 15th partial sum for the geometric sequence. That's going to be this formula. Okay, so we have all our values that we need. So I'm going to find the 15th partial sum, so n becomes 15. The first term, which was 2, times 1 minus the common ratio, -3, raised to the n. Go ahead and close another parenthesis, and then 1 minus -3. Okay, pardon me, n should be 15. So let me adjust that. Okay, so then to complete this problem, just be careful on your calculator. I would do 1 minus parenthesis, -3, close parenthesis, raised to the 15th, get that answer, multiply by 2, and then divide by 4. And this is the result. And that's it.